Hello and Assalamu alaikum everyone. In this video, I will be covering the topic of permutations and combinations. So let's first of all identify what is meant by permutations. Permutations means that you find out the number of possible ways of arranging the objects. If you have a couple of number of objects and you wish to arrange them, then permutations will help you identify that in how many possible ways you can arrange those objects. Like for instance, if you have to put 5 books on a shelf, in how many different possible ways you can arrange those 5 books on the shelf, that is going to be called the number of permutations. Or you have to take a group picture of let's say 3 persons, in how many possible ways you can arrange those 3 persons also refers to the number of permutations. So how do we find out the number of ways of arranging objects? So let's say you have 5 alphabets A, B, C, D, and E, and you have 5 different places in which you have to arrange these 5 alphabets. How can you find out the number of ways in which you can arrange these 5 alphabets in these 5 places? So there are 2 ways to look at it. This is how you actually achieve the formula, the counting principle, in which if you would say that I have to put an object in this particular space. When you wish to put an object in this particular place, you have 5 different options. So you would say, if I will put an object over here in the first place, there are 5 different ways. So you write 5 on account of that. And then once you have filled this space, already one object out of all of these objects have been placed here, and then you have another space where you have to put another object. Since one of the objects is already gone, and we are not specifying which one's gone, but one object is already gone in the first place, so you would have 4 objects remaining here. So to fill up this space, you would have 4 objects available. So there are 4 possible ways in which you can fill this space. By the time you reach to this place, already 2 objects are taken away, they've already been placed in their places. So there are 3 ways in which you can fill this spot. Similarly, there are 2 ways in which you can fill this spot, and there is only 1 way left to fill this spot. So that means that the total possible ways of arranging these objects is 5 into 4 into 3 into 2 into 1. The other possible way of looking at the same scenario is that you have 5 different spaces to fill in the first alphabet A. So there are 5 possible ways in which you can place the alphabet A, but once you have placed the alphabet A and you move on towards placing alphabet B, you would have only 4 options of placing it because one of the places is already occupied. Similarly, when you're putting in C, you have 3 spaces remaining for C. So that's why multiplied by 3, and then 2 spaces for D, and there will be only 1 space left for E. So that again comes down to 5 factorial. Either way, your judgment would be that there are 5 into 4 into 3 into 2 into 1 possible ways of filling these 5 slots. Now this is basically, so you can, like, this entire thing can be written down, like in short we write it down as 5 in this sign, which is for factorial notation. So it means it's read as 5 factorial, which means that this is equal to 5 into 4 into 3 into 2 into 1. So whatever number you see over here, that keeps on getting multiplied till you reach 1, and that's basically how you read the 5 factorial. Try to generalize this. To generalize this, we can say that if we have n objects to be placed in n different places, then the total number of possible ways of doing that would be n factorial. That's how you can find the number of ways of arranging n objects in n different places. Now, what if you don't have same number of spaces as the objects you have? You can still find out the number of arrangements. For instance, again, you want to take a group picture. You have 5 friends, but you just want that group picture to have 3 of them. So it could be any 3 different combinations of those 5 friends and then arranging them. So if you are trying to find out the number of possible arrangements, then you would say that if I have to place the object in the first space, I have 5 possible options to fill it with. So that will be 5 ways. And then when I move on to fill in the second space, then since one of the alphabet is already being occupied, then you are left with 4 alphabets. And hence, to fill in the next spot, you have 4 possible ways. Moving on, if you want to fill in the third spot, then you would have 3 possible ways. If I have to arrange 3 objects out of 5 objects, so the number of possible ways of arrangement would be 5 into 4 into 3, and that gets you the total possible number of arrangements. We wish to generalize it. So if I have something written down as 5 into 4 into 3, I can also write it down as 5 into 4 into 3 into 2 into 1 divided by 2 into 1. So I've actually multiplied by the numbers which were missing to write it down as factorial, and since I multiplied that, so I would have to divide as well. And once I do write down that, I can see that this is 5 factorial and this actually becomes 2 factorial. So I can write it down as 5 factorial into 2 factorial, and I can also recognize that since I had 3 spaces, so this 2 is basically the difference of 5 and 3. So I can write it down as 5 minus 3 factorial. So this becomes 5 factorial over 5 minus 3 factorial. That's your way of finding out the number of arrangements, but there's a standard way of writing it down, that is 5p3. P stands for permutations here. So if you want to find out ways of arranging 3 objects out of 5 objects, that's going to be 5 factorial over 5 minus 3 factorial, and there's a short notation for that, which is 5p3, and you directly have a function in your calculator through which you can calculate the number of arrangements. So 5p3 is something you can directly calculate with your calculator. Hence, we have this standard formula for the number of permutations, which is NPR, and NPR is basically equal to n factorial upon n minus r factorial. So that's how you can get yourself the total number of arrangements. Moving on, there is a possibility that you have to arrange objects, but you have different choices for different places. Like for example, I have to arrange 3 objects out of certain number of objects, then I have to arrange 2 more objects out of certain other number of objects. So I would have a certain ways of arranging these objects that can be determined by using a formula. I would have another number of ways of arranging these objects here, and that would have another formula. But if I multiply these two, then I will get myself the all possible arrangements. So if you have to arrange R1 objects out of N1, R2 objects out of N2, and R3 objects out of N3, then total number of arrangements would be the product of all of them. For example, if I have to make an 8-digit password and it has 4 alphabets and 4 numbers, what are the possible ways of making these passwords? So I know that, I have total 8 options available, and if I have to make an 8-digit password, so that's going to be 8 factorial. But if I put a condition that the alphabets and digits should appear alternately, so I know that I could have an alphabet and then number and then alphabet and then number, so I will find out how many possible ways I have of filling these spaces with alphabets. That's going to be 4 factorial. Then I'll find out how many possible ways I have of arranging these 4 numbers. That would be again 4 factorial. So this is going to be 4 factorial multiplied by 4 factorial. But it could be starting with an alphabet, or it could be starting with a number as well. So whatever is the total possible number of arrangements that I'm getting, that is going to be multiplied by 2. Let's have a look at another example. We have to arrange 7 out of 12 students for a group picture. 5 of them are boys and 7 of them are girls. If I would put no restriction, then out of these 12 people, if I have to arrange 7 students in a group picture, so that is going to be 12p7. But if, let's say, you have to put a condition where boys and girls are to be standing alternately. So there is a possibility that the alternate arrangement starts with a boy and ends with a boy, or there's a possibility that it could start with a girl and end with a girl. So if I look at these possible options, then it's going to be 4 boys arranged here, that's going to be 7p4, and then I have 3 girls, that's going to be 5p3. But if it starts with girls, then I have 4 girls standing here, that's going to be 5p4, and then I have 3 girls standing here, that's going to be 7p3, and then I add it up. I would also want to highlight one thing over here. A lot of students many times are confused about when to add and when to multiply. As you can see over here, I've been multiplying, but here over in this particular position I have added. Or you could also see that in a way multiplying by 2 means that I've added this number twice. So basically it's like, if you would sort of try and look at it this way, that if you are arranging objects into certain places, till the time all the places are occupied and you're putting in objects, you keep on multiplying. But once you have, with a certain set of conditions, filled in all spaces, and then you wish to refill in those spaces again. So if you restart filling them in, then you put a plus sign. So you could see that I had arranged 7 of them, and then I wished to rearrange 7 of them, then I had put a plus sign. But till the point of time I had not arranged all 7 of them, I was multiplying. So that's the trick behind when you have to add and when you have to multiply. Similarly, if you would look at how you would make 4-digit numbers using these digits available, but the number has to be greater than 3000. So if you look into a little more detail of that, you have to make, if there was no restriction like this part and it was just said that you had to make a 4-digit number, so you would say 6p4. But here there is a restriction. It says the number has to be greater than 3000. How would I make sure that the 4-digit number is greater than 3000? By making sure that its first digit should not be 1, because if it's 1, it would be less than 3000. If it's 2, it will be less than 3000. So my first digit can be either 3 or 4 or 5 or 6. That will make sure that it is greater than 3000. So what are the possible ways out of these digits to fill in the first slot? That's going to be 4p1. But once I fill in this first slot, these numbers could be any of these numbers. So if I have 6 numbers available, I've already put one number here, which is out of 3, 4, 5, or 6, but I am 1 less in my possible options, which will mean that the remaining numbers that I have available are 5, and the remaining spaces that I have available are 3. So that's going to be 5p3. But more interestingly, something that I'm trying to highlight over here in these different examples is that if I have arranged one object and then I'm arranging the rest of the objects, I'm going to multiply. And similarly, if the number has to be odd, then my last digit has to be either 1, 3, or 5. And to make sure that the last digit is 1, 3, or 5, that's going to be 3p1 ways. And once you've done that, then obviously the rest of the 3 slots could be filled in by any number, and that's going to be 5p3. Sometimes you could have different possibilities for different slots, but even those possibilities could be like sort of overlapping. So what I mean to say is that, like, let's say you have let's say 10 objects available, and out of 3 objects have a condition of filling here and 4 objects have a condition of filling here. Generally speaking, I would be like that 3p1 would go here and 4p1 would go here. But what if the options that are available for this slot, not all of them, but few options are available for this slot as well? So that means that this is arrangement with overlapping possibilities. And that's where the confusion arises. Like, for example, if I would say that I have to make I'll just make a simpler example here, that I have to make a 3-digit number with the digits that are available, which are 3, 4, 5, 6, 7, and 8. And let's say my first digit could be 3 or 4, and my last digit could be 4 or 5. So I would say that this is basically a situation where I have overlapping possibilities, because the 4 is available for this one as well, and the 4 could be here as well. And the confusion arises because if I would put 3 here, then my options for the last slot would stay 2. But if I put 4 over here, then my options for the last slot would reduce by 1. So this is basically what happens in cases where you have overlapping possibilities. And wherever you have overlapping possibilities, what you would do is that you will split it up. Like you will first find all arrangements with putting 3 here, then you will find all arrangements with putting 4 over here, and then you will add them up. You can see, like for example, if it says how many 4-digit number can be made using 1, 2, 3, 4, 5, 6, and 7. So that's pretty straightforward. That's going to be like if I have to have a 4-digit number, that has to be 7b4. That's pretty straightforward. Then it says how many are even. So my last digit has to be even, and that's going to be 3p1. Then I would be left with 6 numbers for 3 slots. So that's going to be 6p3. Then it says how many numbers are greater than 4,000. That's also pretty straightforward, because if it has to be greater than 4,000, then my first slot could be either 4, 5, 6, or 7. So that becomes 4p1. And then I have 6 numbers remaining for the last 3 slots. That's going to be 6p3. But then it says how many are even and greater than 4,000. So that means it has to be both. It has to be even, and it also has to be greater than 4,000. So to make sure that it's greater than 4,000, the first slot could be either 4, 5, 6, or 7. And to make sure that it is even, the last slot has to be either 2, 4, or 6. The problem arises is that 4 and 4, 6 and 6 are the overlapping options. And since they are overlapping options, then that actually raises a bit of a concern that if I put 4 here, then I'll be 1 less for the last slot in terms of possible options. But if I put 5 or 7 here, I would still have 3 options. So to cope with these kind of situations, you can split it up into different possibilities, like 4, 5, 6, 7, with the last slot be either 2. And you could do the other way around as well, 2, 4, 6, and then you can take different options for the first slot. I'm taking 4, 5, 6, 7 and different options for the last slot. So my last slot could be 2, then my last slot could be 4, and in case if it's 4, then there is going to be 1 less option. So there's going to be 5, 6, or 7. And if my last slot is 6, then also I would have 1 less option, and that's going to be 4, 5, and 7. So I will find out the different possible options for this, like 2 putting here is 1 factorial, then 4p1, and then since I had total 7 numbers available and 2 have already been placed, so the remaining are 5, which can be put in 2 places. That's going to be 5p2. Then in my last slot, I could put 4. That's going to be 1 factorial. Then in my first slot, I can put any of these 3 numbers. That's going to be 3p1. And then in the middle, I can put 5p2. Similarly, if I put 6 over here, that's going to be 1 factorial, 4, 5, and 7 to be placed in the first slot. That's going to be 3p1, and then 5p2 for the middle 2 slots. So that's how I can find out the ways of arranging different objects with overlapping possibilities. Although I have covered it briefly earlier on as well, but there are situations where you have to arrange objects alternately. So if you have to arrange objects alternately, like for example, you have to arrange alphabets and digits, like A, B, C, D, and E, and 1, 2, 3, and 4. So if you have to arrange them alternately, these are going to be alphabets, and these 5 alphabets can be arranged in 5 factorial ways, and these 4 are going to be numbers. That's going to be 4 factorial, and you just multiply them. But if you have 4 alphabets and 5 numbers, definitely you have to start with number. You don't have an option. You can't start with alphabet and make sure that all of them are arranged alternately. So 5 numbers in 5 factorial ways, and then 4 alphabets in 4 factorial ways, and then you can multiply and you can get yourself all possible arrangements. But what if you have 5 alphabets and 5 numbers? So if you have 5 alphabets and you have 5 numbers, then in that case, you know that you can start with alphabet and end with number, or you can start with number and end with alphabet. So these are 5 factorial into 5 factorial. These are again 5 factorial into 5 factorial. So you can either add it twice or just multiply it by 2 and you will get the total possible number of arrangements. So guys, next up we have to say the number of ways in which we can arrange the objects by making sure that specific number of objects are together, or maybe not together, or maybe separated. And obviously you have to pay more attention towards identifying what's the difference between these two. So they sound very similar, but there is a difference between them, where the difference starts from more than two objects. Because if you have two objects which are not together or which are separated, it's the same thing. But if you have three objects, and if these three objects are together, and if you would say that two objects are together and one is away, then you will still say that they are not together, but you can't say that they are separated. They are separated only if there has to be something in between all of them. So that's the difference between not together and separating. So anything like this can be counted as not together, but cannot be counted as separated. Separated means that two objects cannot be together as well. So let's take an example that you have a set of three boys and two girls, and they are to be arranged. And you do know the basic principle is that the number of ways of arranging these five people could be 5 factorial. But let's say if you have to take a group picture in such a way that two girls have to be together. So how do you deal with that situation? With those five objects being there, you'd consider two girls together as one object. Since you would count them as one object, so obviously the total number of objects that you would have would be 4 now, because two girls are now considered together, so they are going to be considered as one object. So if I will say in how many possible ways I can arrange these 4 objects, that's going to be 4 factorial. Keeping in mind, the fact remains that these are two different girls. We've put them together as one object, but they are definitely movable. So we can move them in a way that one girl can take the place of the other. So the ways in which these two girls being together can be rearranged could be 2 factorial. And that's why this is going to be 4 factorial into 2 factorial. But if you want girls not to be together, that is just like the total number of arrangements minus the number of arrangements where the girls are being together. So if you would do 5 factorial minus 4 factorial into 2 factorial, they will not be together. How you deal with the situation of them being separated is that you forget girls for some time and you just arrange boys with spaces. So boys, and there are spaces among them, and then obviously if you have these 3 boys to be arranged, there would be 3 factorial ways. And to make sure that the girls are separated, they can be placed anywhere in all of these 4 places. So if you put 2 girls over here and here, they would be separated. If you put 2 girls here and here, they would still be separated. This or this is also another possibility of them being separated. So we can put girls in any of these 4 places. We have 2 girls, so putting those 2 girls in these 4 places is going to be 4p2. Keep in mind that this number always has to be bigger than this number. It doesn't matter that you have objects more or you have slots more. You just have to make sure that whenever you write NPR, this number has to be a bigger number. And that's how you can get those arrangements where you make sure that the girls are being separated. The same thing could be done with boys as well. I mean, let's say in this particular situation, we want the 3 boys to be together. We could make them as one object. So 3 boys together is one object. And then that makes total objects to be 3. That is 3 factorial. But these 3 boys can shuffle among themselves. So the total number of ways of arranging these 3 boys is going to be 3 factorial as well. So that becomes 3 factorial into 3 factorial. Not together means again total arrangements minus the arrangements where the boys are being together. And if you have to separate the boys, then you will forget the boys for some time and just put girls with spaces between them. And then 2 girls can be arranged in 2 factorial ways, and then boys can be put in all of these 3 places. So that is going to be 3 factorial. So next up, we can be having situations where we have to arrange objects. And previously we've been talking about situations where we're putting objects, but obviously those objects cannot be repeated. Now, if there's a situation where we are allowed to repeat those objects, it can't be with the person, obviously. If you put one person, you can't put that person again. But let's say if you're arranging alphabets, and let's say there is a possibility that the same alphabet could be written again. So there is a possibility that repetitions could be allowed, and the same thing happens with the numbers. If you're arranging numbers, and the same number can come again, so repetitions must be allowed. So we have seen that if we were looking to arrange n objects in n places, for instance, let's say if we were arranging 5 objects in 5 places, we said that every time we put one object in a place, we are one less for the options, and that's why it used to become 5 into 4 into 3 into 2 into 1. But if you are arranging the n objects in n places where repetitions are allowed, that will mean what? Once you have played the first object and you had 5 options for that, and when you start on putting in the next object, because the object that you have placed can be repeated, so you still have 5 options. And then you put the next object, you still have 5 options, and then you have 5 options, and then you have another 5 options. So the total number of options are going to be 5 to the power 5. Or if you're arranging r objects out of total n objects, without repetitions, it was npr. But if you're arranging 3 objects out of 5, so that's going to be like you have 5 options for the first one, then you have 5 options for the second one, you still have 5 options for the third one. So that's going to be 5 to the power r. So with objects and slots equal, the total number of arrangements are going to be n to the power n. With objects and slots not equal, then total number of arrangements are going to be n to the power r. Like for example, if you look at this particular question where you have 6 digits are available and you have to make a number. And if no repetitions are being allowed, so there are 6 factorial ways. And if repetitions are allowed, which will mean that one of the numbers, it's a 6-digit number, so that 6-digit number could also be like this. Or that 6-digit number could also be like this, because you're saying that the repetitions are being allowed. So if your repetitions are allowed, so that's going to be 6 to the power 6. Similarly, if you had to make a 4-digit number, the total arrangements would be 6p4. But if you had repetitions being allowed, so that's going to be 6 to the power 4. Moving on, I could probably be in situations where I have to arrange objects in a way that there are some objects which are identical. Like for example, I have to arrange n objects in n places, but few of those objects are identical to be placed. Which will mean that I may be arranging, like let's say 10 books, but out of those 10 books, I mean I have 3 books which are exactly identical, 2 books which are exactly identical, and then 5 books which are exactly identical to each other. So when I'm arranging these objects, I will write down 10 factorial, but I'd have to recognize that shuffling them together would not make any difference. So when I wrote 10 factorial, I did consider all possible shufflings, but since these shufflings are to be eliminated, so I'm going to have to divide it by 3 factorial, and then by 2 factorial, and then by 5 factorial. So that means if I have to see the total possible number of ways of arranging all the letters of the word arrangement, although it's going to be 11 factorial, but I would also recognize that A and A is repeating. So if I switch them around, it wouldn't make any difference. So I'd write 2 factorial for that. Or if I have 2 R's, I write 2 factorial for that. I have 2 N's, and then I write 2 factorial. So everything, even E is repeating, so there are 2 factorials for that. Similarly, if I have to arrange the letters of the word commitment, so I can see that there are 3 M's, so I divide it by 3 factorial. Or if I see that there are 2 T's, so I'm going to divide it by 2 factorial. And that's how I can get all possible ways of arranging these objects. We need to identify the number of combinations, which is also something that refers to ways of selecting objects. The only thing that's different between permutations and combinations is that in permutations, the order or the arrangement is significant or important, whereas in combinations, the order is not significant. The order is not going to be important. Like for example, if you are, let's say, if you are making a group picture, where it really doesn't matter how you put them in the order, but it just does matter that which 4 persons out of 10 persons do you select for that picture. So in that case, it is going to be referred to as combination. So combinations, to identify which situation, which question is specifically for combinations, the only important criteria that you have to see is that whether the order is significant or not, which will mean that if you reshuffle the objects and that creates a new possible option, then that is going to be arrangement. But if you shuffle the objects but that doesn't make any difference, then this is going to be called the combination. And in case of combination, like for example, if I'd say that I have 7 objects to be arranged, but it's a combination. The order in which I put those 4 objects doesn't really matter. So you would see that it's going to be like, if I would say the total number of ways of arranging 7 objects in 4 places, so that's going to be 7 into 6 into 5 into 4. But since the arrangements don't matter, so 4 factorial would be the possible ways of arranging those objects. So I'm going to divide it by 4 factorial to make sure I do not account for the ways they are being arranged. I can mathematically rearrange it because it was not a whole factorial, so I can introduce 3 times 2 times 1 and divide it by 3 times 2 times 1 as well. So this becomes 7 factorial divided by 3 factorial times 4 factorial. So you can say that that's 7 factorial divided by 7 minus 4 factorial and also divided by 4 factorial. And then obviously there's like a little complicated mathematical calculation. So there's a direct way of calculating it through calculator. You have an option of finding out number of ways of combinations, which is 7C4, and you can quickly get your answer with that. So you can generalize and you can say, if you have spotted a question of combinations where the orders don't matter, then selecting or finding out number of combinations of R objects, R of n objects, it's going to be directly NCR. So if I have, let's say if I have 5 different books to be given to 3 students, so the possible combinations are going to be 5P3, because obviously these are 3 different books and I have to give them to 3 different students, so obviously order would important. But if I have same exact identical book, like it's your physics book or it's your math book, which is exactly identical, it's the same exact book, it could be a same English novel as well. So if it's identical, then in what order I distribute these books to those 3 individuals, it wouldn't matter. And in that case, it's going to become a case of combination, so it will be 5C3. Sometimes the questions are there with some certain restrictions. Like for example, it says a delegation of 4 people is to be sent out of 10 employees. So if I were to ask that, I mean, if I have to select a delegation of 4 people out of 10 employees, that's going to be directly 10C4. And that's my answer for the first part. But when it says that it has at least 1 man and it has at least 2 women, so there obviously it becomes slightly more complicated to view. And in those situations, I would suggest you to make these kind of tables to sort of identify all possibilities. So you have 6 women available, you have 4 men available, and you have to select a delegation of 4 people. So one possibility is that all 4 are men. There could be 1 woman and 3 men. There could be 2 women and 2 men, 3 women and 1 man, and there could be 4 women, all of them. But the requirement is that there has to be at least 1 man and 2 women. So that means you can't have 4 men, all of them. You can't have 3 men as well. You can't also have all 4 women. So you would know that which ones you really wish to consider, and then you can find out these combinations. There's going to be 6C2 times 4C2, and then you have to re-select them. So there's going to be 6C3 times 4C1, and then you add these possible combinations. Also, one possible case of combinations arises when you have to divide objects into smaller groups. So let's say you have a group of 12 people, and that needs to be divided into 2 groups, with each group containing 6. So you would say, I will select 6 people to form 1 group, and that's going to be 12C6, and then I'll be left with 6 people to select another 6 to make another group, and that's going to be 6C6. That's just simply 1, because if you have 6 people and you're selecting 6 people out of them, there's only one possible way. Similarly, if you have to split them up into 3 groups of 4 each, so first group is going to be 12C4. Once you have selected first group, so you have only 8 options available, you make another group 8C4, and then you make another group 4C4, which is, as I said, already 1. So, but I mean, you can write it down as like sort of identifying all possible combinations, but multiplying this or not multiplying this does not make any difference. If I have to make 3 groups of 3, 4, and 5, and it really doesn't matter that first group that I make is of 5 or the first group that I make is of 3. So here I've made the first group of 3, so 12C3, and once I've made first group of 3, so I have 9 people left. That'll be 9C4 to make another group of 4, and then I'll have 5 people left to make another group of 5C5. And similarly, if I have to make 6 pairs of 2 each, so that's going to be 12C2 times 10C2 times 8C2. So you just keep on reducing the total number of options, and you keep on making those groups or pairs and multiplying them all, and that's how you get all possible combinations. So one more possible situation that I would want you to know is situations where you have to make selections from the letters, and let's say, I mean, if you have 4 letters and you have to select 2 of them, so there's going to be 4C2 possible selections. But there are possibilities where the letters that you have to select are repeating themselves. Like, for example, I have to select 2 letters out of the letters of the word possible. So I see that one possibility that I have to consider separately is that both letters are S, and that's going to be just one possible option. And once I have selected S, then I'm left with 1, 2, 3, 4, 5, and 6 options. And plus, obviously, I could also have one S being there as well. So there are total 7 options. So that's going to be 7C2. So I could have either both S, or I could have any letter, any pair of 2 non-identical letters. Similarly, if we look at the word letter and we have to make selections of 2 letters out of them, so there's a possibility that both of them are T's, or there's a possibility that both of them are E's. So both E's and both T's will be 1 plus 1. But once I have added both E's and both T's, so it's going to be 1 letter L, 1 letter E, 1 letter T, 1 letter R, and 1 letter S. So that's going to be 5 possible options to select 2, and that's going to be 5C2. So these are ones which are non-identical, and these are ones which are identical, and you add them up separately to get all possible combinations. I hope you liked the videos. I hope it made your concepts of permutations and combinations clearer than before. If it did help, kindly give a thumbs up and share it with your friends. Thank you, everyone.